welcome to the latest episode of the Making Lean Fly the podcast. What we're talking about this time is TPM, and the title of the show I've used is TPM isn't just about maintenance, because it's a much larger subject than that, and there's much more to TPM, total productive maintenance, than just maintenance alone. Now, I'm really interested and excited to have three industry experts in this. I'll give them the opportunity to introduce themselves in a moment, but we have Edwin Berg, who has a really long experience in this, particularly in Philips Lighting in one of his previous parts of his career. We've got Ben Richardson, who's got a very strong TPM history across multiple industries. And then we've got Mike Fisher, who, as well as his previous experience and expertise in this, is actually one of the key authors of the TPM approach for GK and aerospace. So, we've got three real experts on this podcast, and I'm really excited to listen to them tell us a bit more about that. Just before we go over to that, for listeners, please remember to subscribe to the podcast. And you're very welcome to also see the podcast in live, a videocast, I should say, if you so choose. But I can understand if you would rather just listen than also look at us. So let's do an introduction. So let's start with you, Ben. Would you like to give a brief introduction, please?
Yes. I have a master's degree in industrial technology, and prior to working for GKN, I spent approximately 3 years as a senior change manager for a medical device company. And before that, I spent a little over 14 years as a process engineer, facilities and maintenance manager, and lean manager for a adhesives and coatings company that did laminate roll-to-roll type work. That's where I got the majority of my TPM experience from.
Excellent. So years of experience in really making this happen in a real environment. So thanks, Ben. Really looking forward to listening to your thoughts on that. And Mike, first time on the show as well. So give us a bit of an introduction to yourself.
Yeah, it is. Thanks, Philip. So yeah, I've Mike Fisher. I've been with GKN for 3.5 years now. Prior to that, 20 years experience in fast-moving consumer goods, which was highly capital investment. A lot of high-speed machinery and almost fully automated, which is again where a lot of my background came. But I actually started life as an industrial engineer before I went into FMCG, and that was with a company that made paper machines. So yeah, I'm an industrial engineer by trade, and then I moved into asset improvement as an asset manager within engineering, and moved from engineering management to production and operations management. So kind of been poacher and gamekeeper, and then of course got into this wonderful world of lean, and I've been on that path for a good 15 years.
Excellent. So once again, somebody who's really been there, seen it, done it, got the t-shirt. So great stuff. And then Edwin, you're certainly not your first time on the podcast, so welcome back. And for those who've not heard from you before, brief introduction, please.
Absolutely, I'm very pleased to be back. So thanks for inviting me, Philip. It's a joy to be here every time. So my name is Edwin van den Berg. I currently lead the Lean Academy for GK Aerospace. I've been doing so for the past 3 years. And before that, like you said, I've worked with Royal Philips Electronics in many different operations roles, and also for 15 years in the realm of Lean and Six Sigma, which is where my experience with TPM and many other methods that we use to improve has come from. It's a pleasure to be here, and I'm very excited to be on the panel together with Mike and Ben, because I truly believe that you have a vast experience that I can learn from as well, as much as I can share from my background. So looking forward to this one.
Yeah, thank you, Edwin. So let's start with the first question. What is TPM? So Mike, maybe you could take that first question, please.
Yeah, sure. So I mean, we can use all the textbook analogies about it being about zero breakdowns, but also we're looking at zero accidents, and we're also looking at zero quality incidents coming from our equipment and driving that performance up. But guess one of the best ways to describe it to the person in the street, as it were, was, is to think about an operator who's working a machine tool, who's operating that piece of equipment. It's almost the same as them driving the car at home. So, when they're driving your car, you don't drive around with an AA mechanic in the trunk, do you, or in the passenger seat, just in case something goes wrong with the vehicle. You drive it on your own. But you've got all these visual indicators to tell you, if something is wrong. We keep an eye on the fuel gauge. We can see the oil temperature. We can see the speed. And then also, because you're around that piece of equipment so much, if something's not right. If there's a rattle or a squeak that wasn't there yesterday, if it starts pulling to the left or the right. So there's these other indicators, these less tangible ones, just the feel that something is incorrect. And when you get those indicators, it's, well, now I'll call on the mechanic, now I'll take it to the garage and I'll get somebody who has got the skills. And it's the same way with a piece of equipment that you're running. I'm there every day, I know the machine in and out, and I know if something isn't right. And it's that partnership with the maintenance team around, what can I do myself to look after the equipment, and can I resolve it myself? But if it is too difficult to rectify, or I don't have the knowledge or the skills, then we call on the maintenance experts to come and resolve it before it gets worse, before it becomes a big breakdown, before it falls off the cliff. We resolve it before it becomes too much of a challenging situation.
Yeah, absolutely. I think that's a great way of describing it, and I like that, because if I look at the abstract for the podcast, I talked about the philosophy of asset management, but I think you've really brought it down to, the crux of what it is and what's meaningful for people. It's that ownership by the people using the machine, in the same way that you have ownership for your car. So I think it's a great analogy. Thanks for that, Mike. And Ben, I'm interested in your view. Anything you want to add or nuance to what Mike said?
Well, Mike did have a great analogy there. I'll add to it. I mean, it's really about having a peace of mind, that the operator has a peace of mind knowing that his equipment is going to be reliable for him, going forward, that they have the trust in it, that they have the ownership in it, to know that if if they see anything or have any issues with it, that they have the ownership to either take care of it themselves or to quickly notify somebody else that there's a problem and it needs to get corrected immediately. So yeah, just really to add to Mike's thing, it's really about the peace of mind, not just for the whole site, but for the operators themselves, to be confident in the equipment they're running and what it's going to do for them.
Okay, great. I mean, Ben, just to give you a little bit of feedback, we do record these live, and we'll put it out as is. But your audio was very poor. Then you sounded. Some of the British listeners might remember Metal Mickey, and you sounded like a bit of a robotic voice then. So maybe it might even be worth trying to dial in rather than use the computer audio. But I think my understanding of what you were saying was just reinforcing what Mike was saying about that real ownership by the operator, giving them the empowerment and the tools to really take ownership for the machine that they're working with. So I think, that ties in. And again, in the abstract, I talked about the key goals of TPM being around 0 unplanned failures, 0 product defects, and 0 accidents. And I'd like to maybe investigate that a little bit more in terms of, why do we need TPM? And Edwin, maybe you want to talk a little bit about that. Why do we need it? What's the reason to put all this effort in?
Well, if you talk about why do we need TPM, it has a lot to do with predictability. We invest a lot in our products, in the products that we build for our customers, and in our processes to reliably build them. But we also need to be aware that when we repeatedly use equipment and processes to build our products to a high quality standard, we're also challenging the designs that we've built to the extremes. Otherwise, there is no value add of us doing something for a customer. We actually build something very special. And it's very often that it's not something that runs on equipment or a combination of equipment that you can simply buy off the shelf, and where there is a lot of knowledge available outside. So getting TPM in, getting the ownership around really understanding not just the process in the product, but your equipment that you use in a specific way to be building that specific value for the customer, that has a very important extra to it. An extra value add is knowing what you're doing, knowing how to use the equipment right, and also knowing when your equipment is challenged to the point that you need to intervene. And it can be as simple as all of a sudden there's oil drops that come from an area that you see on the floor, and it triggers you to say, that's not normally there. Something's happening, and before it's going to stop our process, before it's going to not make us able to deliver to our customer, we need to intervene. And if you have that knowledge and skill and capability to know what it's about and to know what to do, that's going to make a huge difference. So it's pride in the people. It is the capability with the people that drive the car, not just with those special mechanics, but it's also what makes it special. What makes your value add for the customer is what's been driven by TPM. That's to me the why we need it. The predictability, the real quality, the extra value add that this combination of things is meaning.
Okay, that's really interesting, Edwin. And I think, one of my observations with TPM though is that it can take quite a lot of effort. It's quite intensive kind of upfront investment. So I guess that's probably one of the biggest barriers to it. I mean, Ben, what do you think? I mean, how would you convince a site director to invest the time and resource and money into TPM?
Well, I would expect they'd want to get their full entitlement out of their equipment. And by showing how having TPM in place is, one, going to keep their machines running and prevent a lot of additional costs from downtime, unplanned downtime, which is very costly. Also, how it will maintain costs from spare parts, fluids, and other things that are necessary. It's very easy to come up with, this is how much we've spent over the past period of time because of unplanned downtime, because of having to expedite parts, because we didn't have them on the shelf or someplace we could get them really quickly. We were confident we could get them, or we didn't even know what the main risk factors were that we were going to need. So putting together a return on investment type of a document or presentation really isn't that hard, as long as you've been able to capture what has happened in the past. Even if you haven't been able to capture it, you can generally get a pretty good feel for what it has cost and just the pain points that it puts on a site by not having it in place. So, it really shouldn't be all that difficult to convince them that they need it. It's really the time frame to get it all into place and properly in place, and the amount of effort that it does take, because it does require a significant effort and a significant commitment from the personnel to actually do it correctly and get it in place, and then to sustain it.
Yeah, absolutely, Ben. So I think you raise a really interesting point there, and I'm interested, Mike, in your view on this, because to be able to put the business case together, as Ben just described, you must know that you've got a problem, right? So you've got to have some data that's telling you that there's a problem. So is there a little bit of a catch-22 situation where, only those companies that really have got a good handle on the maintenance through, say, TPM will really understand OEEs, uptimes, losses on the machines? So actually, to know that you need to get there, you need to have that data that you might not have because you're not that mature. Is there kind of this catch-22 situation, Mike?
There could be, and there's a risk you start trying to deploy TPM on assets when there's other tools that you might want to deploy first. And if you don't have that good understanding of your performance, then that really is a risk. And I've seen this before with your TPM is about predicting the failure and eliminating those unplanned losses. And early in my career as an asset improvement manager, trying to understand the performance of the equipment when I had an operational team who were screaming at us that it's all downtimes, it's all breakdown, that's why we're not hitting the production plan. There were 65% OEE. It wasn't quite OEE measure, but they were measuring availability and the performance rate. And typically in FMCG, you know, it's 80% availability, 80% performance rate. So 80 times 80 gives you the 64, and then a little bit of quality because they're usually quite good. So that's quite standard. But when I looked at the 35% losses, only 7 of it was due to unplanned downtime. 7%. The rest of it was made up of planned changeovers, labour shortages, production plan, materials not being available, other operational processes failing to deliver to the next stage. So actually, there was a lot more opportunities looking outside of just the maintenance aspect, you know, doing changeover reduction, production planning a lot quicker. I remember back to my early days in GKN, and I think you were out there with us in one of our Dutch sites, Philip, before we put it into a sort of a special measures situation. And I was walking around there with one of our colleagues, Alex, and you know, one of the things we found was the operator was spending a load of time trying to find the next job, the next part to run. So the spindle wasn't turning because he's trying to find the next part, and there was parts everywhere. And I think one of the quick things we identified was, let's put two water spiders in, 2 people who will find the parts. Let's paint a box in front of the machine and have these people find the parts and bring the next part up, so the operator could just focus on operating the machine. And that gave bigger benefit than any amount of TPM could do. And it was really rapid and done overnight. So yeah, there really is a need for you to understand how your equipment is running all of the time.
Yeah, that's a really good point you raised, Mike. So, you know, there can be a problem to solve with TPM, but it might not be the biggest problem. So you've got to be careful as well with TPM. You know, if TPM is a hammer, you don't see every problem as a nail. And we need to make sure that we're focusing on the right priorities with the right tools. That's a great point you make. So just before we move on a bit more about TPM, we do like to find out a bit more about the individuals that are on the show. So Ben, maybe share a personal interest of yours, something outside of work that we may not know about you.
I like to travel a lot with my family. We've done most of the United States, and we're starting to venture out into Europe and Canada. So, you know, we're having fun with that.
Yeah, absolutely. I mean, the US is a big enough place to explore anyway, isn't it? And it's such a diverse landscape. I mean, I've not done probably as much as you have, but I've been around quite a bit of the US, and it's just such a different place from one state to another, and even within a state. So it's can be quite fantastic place to visit. I did the West Coast tour for 3 weeks once, and that was quite phenomenal, moving from, you know, different attraction to different attraction. So yeah, travel's fantastic. It really does open the mind, to use that cliche.
Yeah, and I think that's what we do with most of our free time. So if I have PTO, vacation time, we're usually taking a trip.
Excellent. Oh, good for you, Ben. Good for you. Especially after the COVID lockdowns, I think it taught us all we should get out there when we can. So yeah, great stuff. And what about yourself, Mike? What might people not know about yourself?
Yeah, I'll stick with the Ben's theme of travel. I like to travel. I like to travel and be active, and I'm a big roller coaster fan. So I've been over to the US. You're venturing out to Europe now. I've done the West Coast and the theme parks there. I've done Disney multiple times. But I think my love affair started with it just down the road from where we grew up, Philip, in Blackpool Pleasure Beach. So yeah, that's extended out to the US. But yeah, I like my fun fairs and taking the girls with me. They're grown up loving roller coasters like I did, because I dragged them.
That's excellent. So you've got to go on the Grand National when you go to Blackpool Pleasure Beach, and then of course the big one. But yeah, I'm probably sure at my age there's probably a bunch of new ones since I last went there. But And then Edwin, we've learned about your love of brewing your own beer and looking at neighbours through telescopes and so on. But, what else could you share with us?
Well, I've actually missed out on a music career. When I was 18 years old, I applied for a conservatory study for playing the trumpet. I was admitted, and I could have chosen to become a professional trumpet player and have a career with my love of jazz music. I don't know why exactly, but all of a sudden I realized that was going to be a very challenging career to make a good buck out of if you're not extremely good at it. So I actually went for my second option, which was becoming a mechanical engineer, and I did my master's degree in mechanical engineering. And here I am. I built my career on something completely different than on music, but I'm still enjoying it. Although I must admit that I haven't touched the trumpet since I decided not to go for it.
Oh, that's a shame. Maybe you'll have to pick that up in retirement, Edwin. But what I really took from that was you said that to make good money out of being a trumpet player, you have to be really good at it. But by being a mechanical engineer, you don't have to be that good at it.
Did I say that? Or did I just imply that? No, I don't think that's true. I just believe that I had a better chance of being a very, very good mechanical engineer. How's that?
I'm only joking. I know you're very good at what you do. I just couldn't help but pull your leg at that point. Okay, but listen.
Consider it pulled.
Let's get back to the subject at hand then. So let's talk a little bit about some of the misconceptions about TPM. So Mike, what would you consider some of the misconceptions are?
I think we touched on one before. We talked about the amount of effort to get TPM in place. That there is some, but you can chunk it up and do it in small pieces, and focus on a more machine intensive, machine by machine deployment. I think there's possibly as much challenge and effort in sustaining it with the checks and measures that you put in, because it really is a journey of ownership from the team, and the discipline needs to be there. It's an extension of 5S, of course. It's 5S is around the machine. This is doing 5S in the machine. So having that discipline to do the cleaning checks and the inspections that we need to do is really important, because if we slip, then we're going to see potentially unplanned downtime. And there was an example I had, and that journey of that changing the mindset of people to understand that is really good. And there was an example when we ran an activity just earlier in this year. We spent a full day cleaning a machine down, a big gang of us. And one of the operators, he cleared out the machine turret, the machine head. And when it parks itself on one side, there's a drip tray underneath it that, of course, is there to capture drips. It was swimming in oil for years. He cleaned it all out, cleaned all the head down. It looked great. This drip tray was like brand new because it had been preserved in oil for however many years. It was beautiful thing of beauty. It looked like brand new. Following day we came in and he come running over to me, Mike, look, there's oil in there. There's oil, and there's some drips of oil, no larger than a £1 coin. But he was distraught. He spent all this day yesterday, Mike, cleaning that. Look, there's oil in there again. So, well, that's great, because that drip was there yesterday, but we couldn't see it. Now we can. Brought the whole team over to show them immediately. The engineers who were on the team were, let's have a look. And we could see a nylon pipe that had split. Immediately changed it. And yeah, problem quick fix, quick wipe with cloth, and we're away. So, that thing about the cleanliness, keeping it clean, it's the simplest thing to do, but also the hardest thing, I think, to get people to understand and to keep on top of.
Yeah, that's fantastic. And yeah, I've got that kind of triggers me with something that I think it'd be great for Ben to answer, because one of the things I observe is when you go to a traditional factory, an asset's bought and it's still seen as almost the property psychologically of the company we bought it from. So, it's got the nameplate on it, and it never performs any better than the day it first came in terms of, the boilerplate. Whereas when you go to those organizations that really live and breathe TPM as their spirit, they truly seem to take ownership, and you actually see that they improve the performance of the machine over time. It becomes theirs, to the point that I've been to some companies where the manufacturers of the machines come and learn from them so that they can actually improve their machines, because the users know better than they do how they actually work in reality. Is that, have I got a jaundiced view or an optimistic view there, or is that something you've seen as well, Ben?
No, I mean, absolutely. When I worked for Flexcon Industrial, that's one of the things that we did. We had what was considered really old equipment in our facility compared to some of our sister sites. We had coating lines that these are long machines, 80 to 120 feet long, a lot of moving parts. And they were from the early 80s. And the first thing we did, because we were having a lot of problems with them, and I became the maintenance manager, the site, a lot of problems. And so the first thing we did said, okay, ideally what we want to do is get these things back to 100% functionality, because they had parts on them that weren't being used. There were pieces missing. We had inherited all the equipment from other sites. So we went through and said, okay, what is this equipment supposed to be able to do? What's it supposed to be capable of doing? And then we got it all back to 100% functional. And then we started realizing, well, we're having issues. This was about 2008, between 2008 2010, and we were having problems with a lot of the drives and PLCs starting to have issues because they were 1980s manufactured. So I hired a controls engineer, and we started rebuilding all the controls on the equipment, not just the controls themselves, but changing out motors, gearboxes. Did we want some of these machines to have better capabilities? We would engineer that in and make those changes at the same time. Not to forget the whole safety aspect. A lot of them had push buttons or pull cords, but they weren't where they should be. Maybe there should be a light curtain. So we integrate all this in as well. And instead of spending $2.5 to $3 million for a new line, like some of our sister companies were doing, we were doing full upgrades on our own in-house for about $35,000 to $40,000. That's because we were purchasing not brand new parts from the from the distribution houses, but we were finding brand new what do you call it, parts were on eBay that other companies had purchased for themselves, but they don't need them anymore. There's a name, I can't think of what it's called, but anyway, so we would find brand new stuff, but at eBay prices, and we would put it all together, and we built our own test room. So we had, we'd set up the controls, we'd set up the new motors, everything, make sure everything worked great in the lab. And then we would schedule 1 week of downtime, and we'd go and we'd pull out all the controls, all the HMIs, any motors, gearboxes, whatever else we're going to change. Make sure we had bearings, because there were a lot of rollers, some very heavy ones. Bearings, had everything ready, and we had a plan. We would rewire the whole machine and everything. Myself, my controls engineer, I had one electrician that we had, and one maintenance mechanic. And in a week, we could get it all done, get it up, and then proof it out and have it ready for production the following Monday. And when I say a week, I mean we started Friday night when they shut down, and we worked all the way till the following Sunday evening to make sure that everything was 100%. But when we gave it back to the operators, it was 100%. And they knew it was, because we would have them testing it for probably 2 to 3 days before we turned it over and said, here you go. So it was a really good plan. But making sure that if you do it right and you really plan it out, you can take some old equipment and make it really good. I had a couple pieces of converting equipment from the 1930s, big cast iron things that still ran on bushings. To be honest, some of the bushings we didn't change, because we found if you actually grease them once a day, like you're supposed to, they last for forever. And when you go to change them out, it was really some of the 2 little screws that held them in place. You couldn't change a bearing that quick. So we did that, but there were some places where we did machine the casting out and put actual bearings in. But yeah, I mean, you can take older equipment and really make it make it better than it was, originally, much better than it was originally. It'd save a lot of money doing it.
Yeah, absolutely. Yeah, and it's I do often find that's one of the frustrations where, a site will kind of give up on a piece of equipment and just say we need $2 million or $3 million for this new piece of equipment because this one's old. And actually, if you look after your equipment, it can last a long time and actually get better as you learn the machine and learn how it works. So yeah, great examples, Ben. Thank you for that. So why do we need to worry about not having TPM in place, Edwin?
I think if you take it for face value, TPM gives you a predictable uptime of your machine, but I think it gives you so much more. So if you don't have that in place, you're also missing out on so much more. As an example, when I was a group leader for specialty lamps in lighting, we had a maintenance team that was responsible for maintaining the machine, but also responsible for changeover. So when the machine was up and running, they would prepare the next changeover. And all of a sudden, when it went down, the team would basically stop the line, stop the production, step aside and wait for the maintenance team to come and fix it. That, of course, is not really a TPM situation. It's not like a total productive maintenance team that supports the upkeep of the line and the upkeep of the stream of product to the customer. When we started introducing TPM, it was first seen a little bit like a threat to the maintenance crew, because they saw the operators take on some of the tasks that were their responsibility. And it was some frustration, it was anxiety around, hey, what does that mean for my job? But in fact, if you take a really good look at it, what happened was the maintenance engineers were now freed up their time for doing the things that really are requiring their expertise. And with that, they were able to add more value towards a really good, capable process. So that when they're freed up, they started to develop a good understanding of what the nuances were on maintaining the machine and setting it up for the next changeover to really start at a high quality and good capability for running the next production batch. And it became a cooperation that was beyond belief. There was co-ownership of keeping up the machine. There was immediate response when somebody heard a rattle or saw some measuring gauges go out of control. They would immediately go over to the maintenance team and say, hey, we need your help and expertise, because what we do is not fixing it. And what you can do is you can make sure that we upkeep and make sure that our production batch gets completed and it's ready for changeover. Whilst we're doing the changeover, we'll take some work out of your hands, so you can do both the intricate part of doing the changeover as well as do some preventative and corrective maintenance at all the same time. And that teamwork that was built from those TPM sessions and then going forward really meant an extra drive, an extra engagement, an extra ownership with everyone, and just having a lot more fun while you're at work, making sure together you are responsible, owning that product going out to the customer. That's something you would miss out on if you don't do TPM. It's ownership, it's pride, it's working together as a team, and that gets a real boost from a TPM session.
Yeah, I've had very similar experience, Edwin, with the multidisciplinary side of it, operations, engineering, coming together, doing the initial activity together as a team, the operators learning about the engineering elements, the engineers are understanding the process, which maybe they didn't know, so they learned from that side. And we had the same concerns. Operators now doing an engineer's job, does that mean we need less engineers? And we didn't, of course, we just utilised them better. We spent an awful lot of money at that time sending, a gearbox failure, right, we'll swap one out for a new one, or replacement. The one that came off, we were sending out to a subcontractor to replace all the internals and overall the gearbox or the drive for us. And we were able to bring that in-house and reduce substantially some of the costs of the business. And the engineers felt like they were doing proper engineering now. We set them up in a really clean workshop and they're stripping gearboxes down and they're changing all the internals, rather than I'm just taking one out and plugging another one in, which was kind of the day job for them. So yeah, very similar experiences, Edwin.
Yeah, excellent. Thanks for that addition there, Mike. Great answer between Edwin and Mike there. Thank you. So we're kind of coming towards the end now, and normally we talk towards the end about success stories, but you've already shared quite some success stories. So I guess what I'm looking for is, what advice would you have for someone who wants to make a breakthrough in TPM in their organization? Ben.
Take your time to do a really great risk assessment and identify, the equipment that truly needs it, and not just the equipment itself, but all the auxiliary equipment that that it needs to function properly. I think that's something that when you bring up to like an SSC team, that you want to do TPM on a piece of equipment, they only think of the value added piece of equipment, the machine that's actually doing the value add. They don't think of all the auxiliary stuff, the compressors, accumulators, dryers, hot oil units, all the other things that go into it. So my advice is, when you do that, don't look at just that one piece of equipment. Look at the whole system holistically and say, if I'm going to do a TPM here, I might not do a TPM on all the auxiliary equipment at the same time, but they have to be part of that plan. Because if you have one of those auxiliary pieces fail, your main pieces failed anyway. So make sure that you're looking at everything, and you do a really good risk assessment of the whole process, all of the systems that supply that one machine, and create that great visual management around it as well, because that's really what helps you to sustain it. If you don't have a great visual management around it, things get forgotten, they get lost, they don't get looked at when they should. So all of that's there, and make sure you add it to your KEP process, right? You add it to your KEP process. Make sure you're rolling through it, getting it done evenly, like you should be. And you keep moving through the process, and you don't drop the ball. Yeah, I mean, those would be my first things.
So. Great advice, Ben. And for those listening who don't know what the KEP process is, it's our Kaizen event planning process. It's the way that we adequately manage the priorities around making the big step change improvements. Same question to you then, Mike, please.
Yeah, first, kind of agree with Ben's comment. Doing that criticality analysis on equipment and understanding, if it fails, what is the impact? And quite often, we talk about the frontline machines that are changing the state of the materials for the customer, for the products. But yeah, if I've got a plant room and the compressor goes down in there, and it's delivering air to all of the lines and everything goes down right. So yeah, think about those areas as well, not just the operational equipment that we see. But also, as I mentioned before, you asked the question about OEE and measurement, is make sure that we've got accurate data and it's not hearsay, because often, again, I hear a lot of operational people, they just remember the unplanned breakdown and they don't consider all of that planned in, operational issues, no labour, poor planning, poor scheduling, changeovers, which could provide bigger opportunity to you on your improvement journey and faster than a TPM approach.
Oh, brilliant. Really, really good advice there, Mike. And then I'm going to ask a similar question, but with a different nuance to you, Edwin. So, what I'm very keen on here is, if we talk about, the ancillary equipment, I guess, especially in this high energy cost environment that we're in, some of the ancillary equipment, like air loss, for example, from compressed air, and, an inefficient use of hydraulics can actually, by managing that, can reduce the cost to the organization significantly. And then also, we've probably not done justice enough to the safety elements of good TPM as well. So maybe you want to close us off, Edwin, with talking about those 2 points.
I think you're putting a really important point on the table here. If you talk about compressed air, one of the big frustrations that people have is the noise it makes. The fact that you can hear it, and the fact that you need to wear earplugs to protect yourself from the high frequency noise and the high decibels that it can generate. So taking a really close look at reducing the noise levels and reducing the leakages is beneficial for the people that work in the environment that uses compressed air, as well as to the energy cost, because one of the most unseen costs is the amount of electricity that we use with our compressors to generate compressed air. We've had a very good Six Sigma project actually recently in GKN Aerospace that made me think of a very similar project in Philips Lighting. Within GKN Aerospace, we used a visualization monitor to find vacuum leaks for autoclave processes, and you could actually see where we had the leakages in the bagging process. We did a very similar thing in Philips Lighting, but we used the same monitors for just looking around to see unaudible leakages in the compressed air system. And we found plenty. And it's a reasonably cheap priced tool, but it saved us hundreds of thousands of euros in energy costs just by walking around and being able to visualize those leakages. That can make a huge difference. And it's very similar to hydraulics. You're absolutely right. Imagine that you have a small leaking hydraulics pipe and you don't see it. Over time, that leakage will increase, where all of a sudden your hydraulics can pop. That can be a huge safety issue. It can have detrimental effect on the process that you're running with. It can be a huge cost as well. So making sure that you look at your auxiliary processes, at your auxiliary elements that you need to come to the line, and making them part of a TPM approach actually can deal with a lot of frustrations with people, can make for a safer workplace, and can reduce cost tremendously. So it's a really great point that you put on the table there, Philip.
Yeah, thank you. Thanks, Edwin. So I think we've come to the end of the podcast, unfortunately. I've really been enjoying the discussions. I think once again what we've shown here in the discussion is that, you know, like everything in the lean operating model, it's taking a systematic, holistic approach. It's not just going in with a tool. It's understanding the business problems that can be solved by applying a tool such as total productive maintenance. So I think TPM, hopefully to the listeners, has been shown to be more than just about maintenance. It covers safety, of course. It engages people. It creates ownership, and it solves some of the biggest issues we might have in terms of making our customers happy and working in an effective way. So I'd like to thank you, Ben. It's been great having you on the show. Thank you very much, Mike, as well. And once again to Edwin, thank you very much. And to the listeners out there, remember, it's about changing how you lead, not who you are.